Okay, so I'm going to go ahead and resume this video. And I think where I left off on the first part, I think we had already done this problem. I'm going to go ahead and do this again and then let you try to do these two problems down here. And then we'll resume and finish up this section 4.1. All right, so what we're doing on this is we're doing this one by elimination. Okay, and that's what we're going through. So what you want to do first of all, when you look at this, is decide which of the variables that it is that you want to eliminate. And when we go through and do this, I'm going to make a decision on this problem to eliminate these. Now, I could also eliminate the x's. If I eliminated the x's, then I would want this to say 4x, and then I would want it to say negative 4x. So I could make this thing become negative 4x. Just to do something a little bit different, I've got like a negative 3y, and I've got a plus 2y. Well, I want one to be negative and one to be positive. So what happens is if I multiply this one by 2, I get negative 6y. And if I multiply this one by 3, I get 6y. So I'm going to approach this problem this way. So let's start by just writing down the first equation. And what we're going to do is we're going to multiply everything in that first equation, both sides, just by 2. And we'll do that first of all. And then just write down the second equation, x plus 2y equals 14. And what we'll do on this one is we'll just multiply both sides by 3. Be sure to multiply every term by the 3 when you do that, okay? All right, and how do I know to make it 6? Well, I'm really doing the least common multiple. So if I got 3 and 2, if you counted by 3s, and if you counted by 2s, see, eventually they overlap at 6. That's the same principle as getting a common denominator. That's what you're just doing a least common multiple. Okay, so here's how we do this then. You do this in your head. Distribute 2 times 4 is going to give 8x. 2 times negative 3y is negative 6y. 12 times 2 is 24. Okay, do the second equation. 3 times x is 3x. 3 times 2y is 6y. And then 14 times 3 is 42. Okay, so we're ready to do that. And when you're doing this system, keep everything together. Now you can just draw a line and add these together here then. So 8 plus 3x is 11x. See, notice those cancel out. That's why we did what we did. So that's gone. And then 24 plus 42 is 66. Okay, so we get that. All right, so now what we got to do, something real simple. We just divide both sides by 11. Okay, to isolate the x. That'll give x equals 6. 66 divided by 11 is 6. So that gives the value of x then. Okay, so that's the first thing that you want to do is that. Then the second thing that you always want to do is just find the other variable. So we want to find y. And you can find y by picking either equation. I would pick the second one. The reason I would pick the second one, number one, the numbers are smaller. Number two, there's no negative in there. Ultimately, it doesn't really matter. So what I'm going to do is take the 6. I just plug that in where I see x in that second equation. And again, it'll work in either equation. So I would have 6 plus 2y equals 14. Solve this equation. You can move the 6 to the other side. So you would have 2y is equal to 14 minus 6. That would be 2y is equal to 8. So what's the answer in your head? Yeah, that would be 4. So divide by 2, and you would end up getting this. You would get y is equal to 4. All right, so what we do is we write the solution as a point of intersection. So we say parentheses 6, 4 is going to be the answer of that problem. Okay, that's how we do that. And then the third thing that you want to do, you want to do this on your problems, is just check your answer because it doesn't take very long. So you plug in to both equations. So the first equation is 4x minus 3 times y. and just plug in and see if it works. It's got to work in both. So 4x times 3y equals 12. We'll just plug in the 6 for x, plug in the 4 for y. That will give 24 minus 12, and that is equal to 12. Okay, so that works in that equation. The second equation is x plus 2 times y equals 14. Do the same thing, plug x in here, plug y in there, so that would be 6 plus 8 equals 14. So see, that verifies that that's the right answer to the problem. All right, so let's move down. I'm going to have you pause the video and go ahead and work these two problems out at the bottom of the page. Do elimination. I want you to do the correct method on this. So do elimination. Make sure you have that down. Be sure to check your answer, so you should know whether or not you've done this right. If it is not right, double check your checking and fix any errors that you made. Okay? All right, so have fun. Okay, so you can go ahead and check and see if you got these two answers. Now, it's possible you would have done these a little bit different than I did. You know, there's no way I can go through and do it every single possible way, because there's several ways you can go about doing these problems. What I tried to pick out was what I thought was the most logical way to do the problem, and what I felt like would be the least amount of work. And I'll explain why I did that. So this first one is 2, negative 3. So I chose to get rid of the y's. The reason I chose to get rid of the y's is because all I got to do is change this top equation to a 3y. I can leave that alone. If you did it the other way, you would have to do the 5 and 2, make both of them become, one become negative 10, the other one become 10. Now, it'll work that way, but if I can avoid multiplying both equations, then I always do that. So what I did is I just multiplied the second equation by 3. Okay, you see when I did that, I got 15x plus 3y equals 21. Okay, so that's what I'm getting there. Then I just write the second equation underneath that. Try to keep your system together as you're doing that. That would be 17x, the y's cancel, that's equal to 34. Divide both sides by 17, you get x equals 2. Now, when you go to finding y, you pick either equation. See, I would pick the top equation because the numbers are a little smaller, and that just is a positive y. It doesn't matter which one you choose, but I try to choose the simplest way to go. So I just wrote down 5x plus y equals 7. Then I plugged in, see, x is 2, so I replace this x with 2. So I get 10 plus y equals 7. I moved the 7 to the other side, so I get y equals 7 minus 10, or negative 3. Okay, for checking, again, you have to check that it worked in both. So the first equation is 5x plus y equals 7. So it'd be 5 times x plus the y value that we got equals 7. So that's 10 minus 3, that's 7. That works out. Second equation is 2x minus 3y is 13. Plug in x, plug in y, you get 4 plus 9. You got those two negatives, so it's 13. Okay, so that's how I went about doing that. Regardless of how you do that, you'll always get the same answer. There's only one answer to these problems. You know, you either just get one answer or you get no solution, or you can get all real number solutions. All right, so there's no other answer to that problem. That's it. Okay, so this one, now see what I'm going to do on this one is the decision I made is, let's get rid of the x's. If I get rid of the x's, I can leave that 8 alone, and I can make this 4 become negative 8. So the way I make this 4 become negative 8 is to multiply by negative 2. Okay, so in my head I know, okay, I need to multiply that second equation by negative 2. So notice I just write down the first equation, I don't touch it, and then the second equation I get negative 8x minus 4y equals 0. That cancels, that gives negative 1y equals 1. Okay, I'm just adding the like terms. Divide by negative 1, I get y is negative 1. Okay, then I pick an equation, I chose the second one, again it didn't make any difference. So I just wrote down 4x plus 2y, and again the y gets plugged in. So I get 4x minus 2 equals 0. I can move the 2 to the other side to get 4x equals 2. Divide by 4, I get 2 fourths. And of course 2 fourths reduces to a half. You can do that in your head if you want to. You're just dividing top and bottom by 2. And then you can see how this checked. Top equation, 8x plus 3y is 1. X is a half. Y is negative 1. Half of 8 is 4. This would be minus 3, so that's equal to 1. Second equation is 4x plus 2y equals 0. Again, x is a half. Y is negative 1. Half of 4 is 2. Get 2 minus 2 is 0. All right, so pause the video if you need to look over that. Hopefully we did that okay. All right, a lot of arithmetic in that. The first key thing is decide which variable you're going to eliminate. All right, so I'm going to move on to this next page here, and we'll do a couple of applications. Okay, and this is systems of equations here. So this says, suppose that the supply and demand equations for printed t-shirts are, this is the supply equation. Okay, P is equal to 0.7 Q plus 3. Demand equation, P is negative 1.7 Q plus 15. So P is a price, and then Q is a quantity. Okay, so that's what it says. P is the price in dollars, Q is the quantity. So we're going to find the supply and demand if the t-shirts are $4 each, and then discuss the stability of the t-shirt market at this price level. So what we're going to do is we're just going to look at a price is equal to $4 each. Okay, so that's what P is. All we're going to do is we're just going to take each equation and plug in. So that first equation is P equals 0.7 Q plus 3. So just plug in the 4 for the price. So we'd have 4 equals 0.7 Q plus 3. And then you want to go ahead and just solve that equation. So you could move the 3 the other side. So you get 4 minus 1 equals 0.7 Q. I'm going to move this over here and finish this up. So that would be, hold on, why did I do that? I think I'm thinking ahead there. I do that all the time. Move the 3 over there. Okay, so what I end up doing is I get 1. So I get 1 is equal to 0.7 Q. Then I can divide by 0.7. All right, and then I can take my calculator if I need to on this, and I'll just round this off. So I'm just going to go 1 divided by 0.7, which gives this. So I'll just round that. Whoops, I'll round that price off. We'll say 1.43. The 8's going to make that price go up. So what we'd end up having, this is a quantity, by the way, so it's not a price really. So let's just say round that to 1.43. So that is your quantity at that particular price level. Okay, and that quantity is in hundreds. So really this would be 1.4300. Okay, on that. Because what it says is the price is in dollars, so I just plug that in. So this is in hundreds. All right, so actually that would be about 143. Okay, so that would be your equilibrium quantity on that. All right, and then we just do the second thing, which is the second equation is P is negative 1.7 Q plus 15. Okay, again, move the, we want to plug in the 4. The price was given as 4. So we'll have 4 equals negative 1.7 Q plus 15. Move the 15, so you get 4 minus 15 equals negative 1.7 Q. 4 minus 15 is negative 11. So I get this. Okay, then I can just divide both sides by negative 1.7. And take the calculator, and again, this will be in hundreds. So I can just take negative 11 divided by negative 1.7. The two negatives are going to divide to make a positive. And we'll round that to 6.47. So we get Q is 6.47. All right, so what we end up getting then is for that price supply equation, we have that. And then for this, you just change this to 647 items, like that then. All right, so what we end up getting is this is the supply equation. So you have a supply of 143 gives, let me close that calculator, gives a price of $4. Okay, so that's what the quantity is. That's what the supply is that gives that price. And then the second thing is a supply, or sorry, a demand, because the second one is a demand equation. So that second one means the demand of 647, that will give a price of $4. Okay, so they're not the same, all right? So the supply and demand are not the same in this. Just means that when you're at a price of $4, the supply is lower than the demand. Okay, so what we end up kind of getting is, at this level, the supply is smaller than the demand. All right, so that's what that means. Okay, now I'll go to the next one. We're going to say find the supply and demand if the t-shirts are $9 each. Now I'm going to have you all do this. It's the same thing I just did. So go ahead and just write down the two equations. We have P is 0.7 Q plus 3. That's your supply equation. Okay, and then write down your demand equation, which is P is equal to negative 1.7 Q plus 15. So what I want you to do is the same thing. Just go ahead and pause the video and then plug in a $9 price and then write a comment based on what you find. Okay, come back, pause the video, check when you're ready. Okay, so checking, here's what you should have got. For the supply equation, you would end up getting Q as 8.57, but since this is in hundreds, like the word says, you have a supply quantity of 857. The demand, again, replace P with 9. Since the price is given as $9, should have got Q as 3.53 or 353. So here's what you get. You have a supply of 856 gives the price of $9, and the demand of 353 gives the price of $9. Okay, you could write that in different ways too. It's probably even better if you say at a price of $9, the supply is 857 and the demand is 9. You can write it like that. So in this case, since the price went up, that's fairly logical. Okay, the price goes up, the supply goes up, because you know who's going to buy this thing. Okay, as this price gets higher and higher, people are just going to say, forget this, I'm not going to buy it. So that makes sense to me. That's kind of what you generally expect supply and demand to behave as the price goes up. Okay, so next thing we're going to do is find the equilibrium price. So the equilibrium price is where the quantity is equal to the price. So we're going to find the equilibrium price and quantity. So what we're going to do is solve this system of equations. So I'm going to go ahead and let's write down the system. We have P is 0.7 Q plus 3, and P is negative 1.7 Q plus 15. Okay, so what's going to happen, we got to solve this system. Now, we don't want to do elimination. I mean, it would be, you could do elimination if you want to. It doesn't really make any difference to me. If you did elimination, you would want the P's to eliminate, probably not the Q's. You could also do substitution, which is what I'm going to do. So what I'm going to do, since they're both solved for P, really what I'm going to make a decision on is I'm just going to plug that into the first equation right there. Okay, now you could do elimination too if you chose to, but if you did, you would want to get rid of the P, all right? So what I'm going to do is replace this P with negative 1.7 Q plus 15. Leave the right side alone. This is just one way to do this. There is numerous ways you could solve this system of equations. I'm just going to choose to do it this way, okay? Now what I'm going to do is just kind of standard algebra. I'm going to get all the Q's over here. And then I'm going to get the numbers over there. So what I'll have then is this will come down, so that's negative 1.7q. That sign will change to be minus 0.7q equals 3, and then moving the 15, you get a minus 15 like that. Okay, if you do this, you can do it on the calculator if you want to. You would get negative 2.4. Like that. You can always do stuff with your calculator if you need to, if you got decimals and stuff. So again, I just got negative 1.7. I'm really tacking on a negative 0.7. Okay, so that's negative 2.4. So I've got negative 2.4q equals, and then 3 minus 15 is negative 12. Then I can divide both sides by negative 2.4 and go to my calculator, so that'll cross that out. This will give us what we call the equilibrium quantity. So I'm just going to take the negative 12 and divide that by negative 2.4, and that gives 5. Now remember that quantity was in hundreds, so really this is 500 items is what your quantity is. Okay. Now what we're going to do now is we're going to find P. If you want to find P, it doesn't matter which equation you use. You can use the top or bottom. I'm going to make a decision to work with the top equation. And then I'm going to plug in the 5. Don't plug in the 500, plug in the 5. So the 5 goes in. So I'd get P equals 0.7 times 5 plus 3. And then you can do this on your calculator in one step if you want to. Just do 0.7 times 5, which is 0.35 or 3.5. And then 3.5 plus 3 will give you what your equilibrium price is. So that price is 6.5. All right, so what you end up doing is you end up getting 500 items. I can't talk and spell at the same time. 500 items, and then you have a price of, that would be $6.50. So that is where the supply and demand are equal. Okay, so they will be the same. Now, one thing I'm going to do on this problem, I want you to do this with me. We're going to go to the next page. We're going to do a graph on this, which of course we're going to do in the graphing calculator. So before we go to the next page, let's go ahead, and what you want to do is go to y equals, and you want to just take the system. You know, let's go up here to the original problem and put this in. Now we can't use P and Q, so we're just going to use Y and X. So you want to put in 0.7 X and then plus 3. And we'll talk about what this means in just a minute. And then you want to put the next one in, negative 1.7 X plus 15. Okay, so your first one is your supply. The second one's the demand. Okay. All right, now I'm going to move to the next page, and then we'll kind of talk about what this is going to mean, and we'll get this put together then. All right, so what we want to do is we're going to make a graph on here, just basically kind of a corner graph. And let's label this as X. And actually, let's label it as, instead of X and Y, let's label it Q and P like this. So this will be the quantity, and you want to write that in hundreds, so that you're telling the person you're presenting to this accurately, and then this is your price, and we'll kind of talk about what's going to happen. Now we're going to have to set up the window on this. Now one thing that happened on this, if you look at kind of what we did in the previous problem, we looked at the price. Equilibrium should be where these two things intersect. So we ended up having 5 and 6.5. So what I'm going to do is, for that reason, I want my price probably to be higher than that, and that quantity to be higher than that. So here's what I'm going to, for that reason, choose to do. Oh, come on, don't screw up on me. Hold on. I don't know what I did either. Here we go. Sometimes I just press the wrong button on here and don't know what I did. All right, so back to what I was going to talk about here on the calculator is we're going to go, X is really quantity, so that needs to start at 0. Let's go up to 10, and then Y is really price, so let's scale the X by 1, and the same thing here, let's go 0 to 10, scaling by 1. Okay, and then I'll kind of show you what my thought process is in setting this up. So if you go back to your equations, see, one of them is sloping up and the other one's sloping down. And I'm going to make one little adjustment on here too, on my window. I'm going to change one thing and I'll show you why I'm doing that. Okay, so if you look at this, let's see, we had 0.7x plus 3. So if you look at P equals 0.7x plus 3, that is your y-intercept. And then your slope is positive. So that means you're going to have a line that's sloping upward. If you look at the second equation, you have P is equal to negative 1.7x plus 15. Well, your y-intercept is 15. Okay, so the way I've got my window now, you're not even going to see it. So I would suggest that let's take that up to 15. Okay, we'll change that. And then the slope is negative, so that means that's going to slope downward. So one equation slopes up, the other one slopes down. So let's make a slight adjustment. Let's change this y to 15, then we're ready to graph. Okay, and I just think that's probably in general a little bit better way to look at that then. Okay, all right, so let me do this, move this down here, and then we're ready to go ahead and graph. So you can go ahead and we'll get set up, and then we'll take a look at our graph. All right, but you want to know why I chose to do this. That's why you have to understand graphing, is because you have to set up the calculator. So you have to understand what the y-intercept and slope and all that means. Okay, so now I'm going to graph. Notice what you'll have is one sloping up, one sloping down. Okay, like that. See, that one had the y-intercept of 15. That's what that one is. And then this one had the y-intercept of 3. Okay, now I'm going to just slide that down there and just kind of get this put together, and then I'll have you draw a sketch on this. So what we're going to do is we're going to take this up to 10. So we just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this is going up to 15. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, $10. And then 1, 2, 3, 4, 5, 15, like that. All right, now see, all you got to do is just sort of estimate these things on here. So this first equation, what you have is you have a y-intercept of 3. And all it takes is 2 points to make a line. So what I'm going to do is I'm going to trace on this. And watch carefully how I do this. I trace, and I want to be on the blue line. I'm graphing this blue one right now. Well, go ahead and type in 10. That'll take you to the end of that graph, so you have a point 10, 10, see. Okay, so you want to get 2 good points on your graph and label them. So that's 0, 3. Then you have this point 10, 10, like that. And then we want to go ahead and connect the dots into a straight line. Okay, like that. All right, so that gives you that equation right there. Now remember, if you look back what we did, that first one that we just graphed, that was your price supply. So what you want to do is just label this as price supply. Okay, so that's the price supply equation. Okay, now we'll do the second one. Okay, now on the calculator, what we know on this one had a y-intercept of 15. So I put a dot there and label that as the point 0, 15. And again, I'm going to trace. Watch how I do this. I trace. Now I want it to be on the red, so I toggle. See, if I toggle up and down, I want to be on the red one. So now I'm on the blue. Oh, come on. Did something wrong, screwy. Okay, there we go. I'm on the red. And then I just trace at the biggest x, which is 10. and that gives -2. Okay, now since that's down the negative numbers, let's just do something a little different. Let's do 8. Okay, that's okay. So let's do trace at 8. So you get 1.4, and then that'll be good enough. So go over 8, and then just kind of estimate 8 and 1.4. That would mean 800 items, you have a price of $1.40. Okay, then what you can do is connect those two dots into your straight line, and then you got a fairly nice accurate graph, and then we want to label this as the price demand equation like that. So see, using your calculator, you're getting a real accurate graph, and you need to do that. If you're drawing a line, get 2 points. I don't care what those 2 points are, but get them and plot them. Don't just draw a line. Get this thing accurate. You guys are business people, most of you, so accuracy is pretty dang important, right? Okay, so the other thing I was going to show you real quick is that equilibrium. So I want to show you this, and I want to show you how you can actually do this equilibrium on your calculator. All right, so what I'll have you write down the keystrokes. So what you can do is you go second, like this. You type second, then you go trace. Might want to write down these keystrokes. And then you go to option 5, which is intersect. Then you press enter. So option 5, intersect, and then enter. So those are the 4 keystrokes you do. Now what it's saying right now is first curve. You're on the first curve. Yeah, okay, so press enter. Okay, now second curve. Okay, you're on the red. Doesn't matter where it is. Press enter. Do it again. When it says guess, press it again. And voila, there you have it. Okay, and that's what we found when we did this algebraically a few minutes ago. So it's kind of cool is if you go through and look at this, that's what our equilibrium was, 5, 6.5. If you go back to the previous problem, 5, 6.5 is what we got. So let's go ahead and just label that as equilibrium is the 0.5 and 6.5. Okay, that's it. All right, see how beautiful that graph is? That's just awesome. All right, so I want you to know how to do technology to do that. All right, so we're going to do one more problem. We'll go ahead and look at this word problem. Anytime you need to pause, pause. So if you need to pause and decipher this a little bit, then please do so. Okay, so we got one more word problem to do. This one's pretty challenging. The hardest part of this one, I think, is understanding what the variables are, what all the numbers belong to, and how to form this system. So to begin with, always, of course, start by reading the problem. I see students all the time, it's a word problem, they throw up their hands and say, oh, I can't do word problem. Yes, you can. You got to work with them, and it's okay to be challenged, and it's okay to think. All right, so here's what this says. A coffee company uses Colombian and Brazilian coffee beans to produce 2 blends, robust and mild. So far, let's just kind of keep in mind there's 2 types of coffee beans that are being utilized, and there's 2 types of blend, a robust, strong, dark blend, that sounds so good, and a mild blend, okay? Then it says a pound of the robust blend requires 12 ounces of the Colombian beans and 4 ounces of the Brazilian beans. Now what I'm going to do is I'm going to just highlight that, and I'm going to write down what that just said. Because right now I don't have a clue how to do this problem. I haven't even read it yet. But this is kind of what I do. So I'm going to just write down information myself. So 1 pound of robust. Okay, here's what it requires. Okay, it requires 12 ounces, so it looks like we have ounces and pounds are kind of out of whack, of Colombian beans. And it requires 4 ounces of Brazilian beans. Okay, so I've got that. All right, read on the next sentence. It says a pound of the mild requires 6 ounces of Colombian beans, 10 ounces of Brazilian beans. A similar piece of information. But now we're trying to make a mild blend. So this says, again, 1 pound of the mild blend. Okay, that requires 6 ounces of Colombian. And it requires 10 ounces of Brazilian. Okay, so by doing that, I've kind of just written down what my information is. Okay, so that's how you make a pound of robust. That's how you find a pound of mild. And notice that the ounces and pounds, we're going to have to do some sort of conversion there probably when we do this problem. Okay, now we read on. Coffee is shipped in 132-pound burlap bags. Okay, so that's another piece of information. 32 pounds equals 1 bag. And that would either be the Colombian or the Brazilian. Okay, so that's another important piece of information. Okay, and let's see. Then it says the company has 50 bags of Colombian beans. Okay, so we got that piece of information there, and I'll just kind of start over again. The company has this, so let's just write that down. So we have this. Okay, we have 50 bags of the Colombian beans, and we have 40 bags of the Brazilian beans. Okay, now what I'm trying to do is trying to give you a strategy for figuring out word problems. And what you got to do is you got to write down everything that you're given. Now, the question, when you read the question, that should generally tell you what your variables are. So here's what the question is. How many pounds of each blend, and the 2 blends are robust and mild, to produce in order to use all of the available beans. So that right there tells you what your variables are. And it says how many pounds. So what we do when we form the system, what we're going to do is we're going to do this. Okay, let's use logical variables. So we got robust and mild. Let's let R be the pounds of the robust blend. Okay, and then let's let M be the pounds of the mild blend. Okay, so those are our variables. Now somehow we got to put all these numbers together and get this formulated into a system of equations. 2 equations with 2 unknowns in it then. All right, so if we kind of begin to put this together, a couple of things that I see here is this is how you have a 132-pound bag of Colombian and you have a 132-pound of Brazilian, but you also have this many bags. So what I'm going to end up doing on this is I'm going to kind of, when I make my system, I'm going to end up having a system of equations that has to do with the Colombian blend, the Colombian beans, and then another one with the Brazilian beans. Okay, so I'm going to try to kind of put this together like this. All right, so this is kind of what I think of here. So I have a 132-pound bag, but I have 50 bags of this. So if I was to go through and do those 2 things, and then I can just multiply this out, I'll probably get some big numbers on this problem. Okay, but let's see, we got the trusty calculator to do this then. So we have 132 times 50. So that means that we have 6,600 pounds of Colombian coffee. Somebody is giggling there. We're not talking about pot here. We're talking about coffee. Okay? All right. Then the next thing we have is we have 132 pounds, but we have 40 bags of the Brazilian. Okay? So we're just trying to figure out we have how many pounds of beans we have in total, because we're supposed to use all of this up. So if I do 132 times 40, that gives 5280. All right, so I have 5,280 pounds of the Brazilian. Okay, beans. Beans, beans, beans. Okay, all right. Okay, so we got that. Now we're kind of beginning to piece this together, see? All right. Now, we got to kind of start putting this stuff together. Like I said, we're going to have probably an equation for the Colombian beans, which are making up the robust and mild blends and everything. So if we go through and put this together, if we were going to come up with an equation for the Colombian beans, well, let me just sort of highlight what we have. You have, for the robust blend, that's 12 ounces of the Colombian beans there, okay? And then the Brazilian, you have 4 ounces like that. Okay, so what we're going to do then is kind of use that information together like this. And then we're going to have an equation that just has the Colombian beans then. So here's the way I look at this. All right, so 12 ounces times the number of pounds. Now you got to do a conversion there. Now see, the key thing on here is you got to know that 1 pound is equal to 16 ounces. All right, so what that means is if you divide this by 16, 1/16 of a pound is equal to an ounce. Okay, so that right there, we're going to have to change that to a pound. Okay, so what we're going to do is we have 12/16. That's the fractional part of a pound of the Colombian beans that we're going to use on that. Okay, and what we're doing is that's for a robust blend. So that gives that. Okay, same thing here though. Now we're going to have 6 ounces, so that's 6/16 of a pound, but that's making the mild. And then, see what this is saying, we're making the Colombian blend, so that is 6,600 like that. You got to think about what we do in here. This is telling you that this is basically every time you have 1 pound of the robust, that's what you have. Okay, you have this amount of Colombian beans. You have this amount of Colombian beans to make the mild, and then that total is that. Okay, then we're going to have a second equation for the Brazilian, and it goes like this. Okay, so I'm going to just sort of highlight these things right here. So I'll have 4 ounces. Now I'm making a robust, so I'd say 4/16 of the robust plus 10/16 of the mild, and we have this amount of pounds. The reason I have to convert these ounces to pounds is so I'm consistent. That right there should be the system of equations, and then if we solve that, that'll give us the solution to that problem. Okay? All right, that's what that is. Now what I would do on this system, I'm going to kind of, I think, I may have to move down or to the side here a little bit. I'm just going to cut that out of the way here. And I've got my system, and we're going to focus just totally on solving this system right here. Now what I would do is, instead of even bothering to reduce these fractions, you can get rid of these fractions by multiplying by 16. So what I'm going to do on this is I'm going to take this system and I'm going to multiply both sides by 16. Okay, then I'll kind of show you what happens then. So I would do 16 over 1 times 12/16 r plus 16 over 1 times 6 over 16, and then that would be m. Then I do 6,600, getting to some pretty big numbers, so I do 6,600 times 16. So that gives this number, 105,600. Now what happens is that crosses that out, so you end up with this system, 12r plus 6m equals 105,600. Okay, so that is our first equation without fractions. I'm going to do exactly the same thing to this second one. I want to get rid of that fraction 16, so I multiply both sides by 16. Okay, again, I say I'm doing a distributive property. So what I do is I end up having 16 over 1 times 4 over 16r plus 16 over 1 times 10 over 16m. Then I do 5280 times 16, and that will end up giving 84,480. Okay, again, that crosses out, so we end up with 4R plus 10M is equal to 84,480. All right, so that right here would be our system. After we've got rid of the fraction, that's what we're going to solve this problem. Okay, that's kind of tricky, isn't it? Okay, all right. So what we have on this then is, let's just I'm going to move this over here, bottom of the page, so I can take up a little bit of room to get this done. So let's just write down the system. So I have 12R plus 6M equals 105,600. And then I have the second equation, 4R plus 10M equals 84,480. So the way I'm going to look at this is these things I want to cancel out. I'm going to make a decision to get rid of the R's. So if that's 12, I want this to become negative 12. So what I can do is multiply this by negative 3. Then I would have no choice but to multiply that by negative 3. Okay, and then taking it from here, what we'll end up having is the top equation's unchanged. So we have this, you just bring that down. Then we have negative 12R minus 30M. Okay, I'll take my calculator. I'll do this, so I've got 84,480 times negative 3. And that will give this big number, negative 253,440. And then I'm going to just add this equation together. Okay, that's going to drop out. 6 minus 30 is negative 24M. I need to add this column together, so I can just do 105,600 minus 253,440. Get a negative number. They're going to work the negatives work their way out anyway, it looks like. Okay, so I got that. All right. So now, solving this equation, you want to divide both sides by negative 24. And then we'll take the calculator, and then this will give the amount of pounds of the mild blend that we're going to have then. So we take that number, divide by negative 24, 6,160, so we have 6,160 pounds of that mild blend. Okay. All right, so we did that. Second thing is we need to find R. Pick an equation. I'm going to pick the second equation, 4R plus 10M equals 84,480. Plug in the M that we just got, and then solve this equation. Then we'll try to make sense out of all this stuff we just did. All right, so what I have is I have 4R plus 10 times 6,160 equals 84,480. So this is 4R. Multiply that out. That's 61,600 equals 84,480. Okay, subtract or move to both sides. You'd have 4R equals 84,480 minus 61,600. So that's 4R. Now I'll take my calculator and I'll take 84,480 minus 61,600. And that will give 22,880. So the last thing I do is divide by 4. And we do this. So I take that divided by 4. That gives me 5,720 pounds like that. All right. Now we're going to see if we can make sense out of this problem and see if this is right. Okay, so that's what I got, is I got that for the mild and that for the robust. And that would be the amount of pounds that we use, and that would use all the beans up based on the recipe that we were given. Okay? All right, so let me kind of show you what happens on this problem then. So let's think about and interpret this problem then. I need to pause for just a second here. Okay, now you can check by plugging into your system here, but I'm going to do something else, so just a little bit different. I hope this helps you understand the problem a little bit. The question is, did we use all of the beans? Okay, I'm going to just kind of look at it this way. Well, if you look at this back here, we figured out that we had 6,600 pounds of the Colombian beans. We also had 5,280 pounds of the Brazilian beans. So in other words, how many beans do we have? How many pounds? So if I do 6,600 plus 5,280 on a calculator, that means 11,880 total beans. Okay, well, what did we come up with? We came up with 6,160 pounds for the mild. And then we came up with 5,720 pounds for the robust. Well, what happens if we add this up? That's 0, 8, 8. How about that? We did use up all the beans. Okay, so that's just one thing I wanted to show you on there. And you can also check by plugging in to this system of equations. So you could take 12 times 5720 plus 6 times 6160 and see if it's that number, just plugging it into this system. All right, that's a really difficult problem to put together, I think. But one of the keys to that is, I hope that what you get out of this is always start by just writing everything down that you're given. And then the question on the word problem generally is going to give you the variables. So it said how many pounds of each blend. So that meant our variables were R was the pounds of robust, M was the pounds of mild. Then I got to figure out how to put those into two equations. And I just basically had enough information about Colombian beans. We had enough information to figure out how many pounds of Colombian beans we had, how many pounds of Brazilian beans. We know that because you had a 132-pound bag, and you had 50 bags of Colombian and 40 pounds of Brazilian. That gave those important numbers right there. So that gives you that you have a total of 11,880 beans in total to do. Then you got to start thinking about this information here. And that's probably the most difficult part, is putting that together into equations. All right, so think about that problem, all right? All right, that will take care of everything in this section then. So good luck.